Hey dudes, we're working on 2.9, finding equations of lines. It's out of HE from the text. Jot that at the top of your notes and we'll get rolling. All right, so finding the equation of line, we're trying to work with points and build lines or lines and find the equation, therefore. So this is one of the tricks, like find the equation of a line with this gradient and this intercept. Okay, well, I know one of the equations we're working with is slope-intercept, y equals mx plus c. And this part is the slope, the gradient, that's m. And this part is the intercept, that's c. So you can just plug them right in, say y equals 5. You got to keep the x. It's no longer an equation if you put a value in for x. And plus c, well, I guess we can say minus 3. Okay, so you try that if the gradient is 6, 1/6, ooh, and the intercept is negative 5. All right, pause and try that. Cool. It'd be the same thing. You'd just say y equals, the gradient is 1/6, so leave it as 1/6. All right, x plus c, all right, minus 5. Great. If we were to graph that like we did before, we'd graph this one, 5x minus 3. We'd start at negative 3, 1, 2, 3. We'd start there. That's this part. And then we'd rise and run with this slope. The slope is 5, so 5 over 1. So rise 5, run 1. So from here we'd go 1, 2, 3, 4, 5, up, 1 over. That's your next dot. And then draw yourself a line through it. If you could. Nice shot, Dorkevich. Let's try it with this. Like that, right? Okay, you can do the same thing with this other value, with this other equation. If you're trying to graph this, you're saying let's start at negative 5. So 1, 2, 3, 4, negative 5. And then you rise and run like this. You rise 1, run 6. So from here you rise 1 and run 1, 2, 3, 4, 5, 6. There's your next point. Those are your 2 points. You draw your line through them. You move on with life. Cool. Okay, so this is, the line has this gradient or slope, passes through this point. This is an x and a y coordinate, right? Find the equation of the line. Okay, I know we're looking at y equals mx plus c. That's usually the easiest to graph. I always write this down. It makes it way easier, right? So let's see. This is the slope. We can plug it right in, right? So y equals 2/3 x plus c. I don't know c, but I do know this x and y coordinate. So I know that if I put 3 into the equation, in for x, we already have 2/3. If we multiplied that by x, I don't know c, but if we put this x value in here, we should get out this y value, right? We should get out 1 for y. I know this point works on the graph, so I know it has to go in and multiply this and get 1. So therefore c is the only thing I don't know, and we can solve for c. So you'd say, oh, 2 divided by 3 times 3, these actually cancel out. So you're left with 1 equals 2 plus c. And then when you solve, you subtract 2, and you get c is negative 1. So your equation looks like y equals the slope that we know has to happen, 2/3 x. We want to leave the x in there because we want an equation, right? And then plus c. Here's the c that we figured out. So there, minus 1. And you can always check it, right? You can just check that it works by putting in 3 into the x, 1 into the y, and see if it makes sense. So this would be 2/3 times 3 minus 1. Does that give you 1? This is 2 divided by 3 times 3. Those cancel out. You're left with 2. 2 minus 1. Does that equal 1? Does 1 equal 1? Yeah. Last time I checked. Great. Ka-ching! So we know our equation works. Yeah. You try that with this. Play the same game, but try that with 2, 4, and let's do a slope of 3. Just straight up 3. Cool? Pause me and try that. Okay, so we'd be doing the same sort of thing. We'd say y equals mx plus c. They told me this is the slope, or I told you that's the slope. So you can plug that in. Y equals 3x plus c. I don't know c at all, but I do know that this is an x and a y coordinate, 2 and 4. So if we plug in 2 into the x and a 4 into the y, the only thing we don't know is c, since we do know the slope. Right? So I just plugged x in for x, y in for y, and now I'm going to solve for c. So this is 6 plus c is 4, and so you can subtract 6, you get c is -2. They said find the equation, so you got to write it out at the end. Y equals the slope that they asked us for, or told us about, and then plus c that we found out. Ta-da! Ching! If we were to graph it, it would look like this, starting at -2. So it'd start at 1, 2, -2. And it would, this is the slope, so it's 3 over 1. Rise 3, run 1. So 1, 2, 3, run 1. There's the next point. Draw the line. Da! Sweet, moving on. Okay, so find the equation of the illustrated line. This is the same idea as this. They give you a point, and they give you enough information to find the slope. So this is, I know it says -2, but it's really at -2 down and 0 over. -2 comma 0, right? So I might erase that and just kind of like put that like that. Okay. So if only we had the slope, like before we were using a point and a slope, I don't have the slope. Oh, we can find the slope. The slope is how much, we can find the slope from this point to this point. So it rises from, oh, sorry. Why didn't you tell me about that? Come on. It's 0 over -2 down. Quack. So this rises from -2 and then goes up to 2. So it rises from -2 up to 2. So 4, rise over run, right? And the run is from 0 over to 3. So that's 3. So there's our slope, right? If you're not sure how to get that, go back to the slope videos. I'm assuming we're good with that. So now I know that it has this slope and goes through this point, or goes through that point. It really doesn't matter. I don't really want to work with the negatives, so I'm going to choose this point. Yeah. So we can play the same game. Y equals mx plus c. Let's plug in. This is an x value. That's a y value. So let's plug in the x into the x. Oh, I know my slope is 4/3. 4/3. Let's plug the x into the x. I don't know c, but I can plug the y into the y. If I plug in this 3, I should get out the 2. I don't know c, so you can solve for c. Let the 4 divided by 3 times 3, those cancel, and you're just left with 4 on this side, and plus c. And then you can subtract 4, you get c, these cancel out, that's 0. This is -2, and so your equation looks like y equals the slope that we figured out, 4/3, x, don't forget your x or else it's not an equation, and then plus c. Pause me and try to do that same thing using this point. We're going to assume we got the same slope, but make sure you can get this same equation using this point and the slope we figured out, because you should be able to get it either way. Cool? Go for it. Okay, hopefully you pause me, and we're going to use this other point. So I know our slope is 4/3 x plus c and y. Oh, but I do have an x and a y coordinate. So if I plug in 0 into the x value, I should get out -2 for the y value, and I know our given slope. Yeah. So 4/3 times 0 is 0, and c is -2, and so we'd write our equation y equals the slope and the c value. Hey, same thing. This was actually easier because the 0 canceled out our fraction. Which one's better? It doesn't matter. They both give you the same solution. Hooray. Moving on. All right. Last one. The equation of the line which passes through this and this. Now, we could go steal a graph, paste the graph, plot the points. Sorry, blew up. Plot the points. Here's -1, 2, and 1. Here's 1, 2, 3, 4. Oh, 1, 2, 3, and then 16. And we could go from there, right, with these points. Yeah, that's fine. And maybe I'll kind of do that. I know that's not actually at 16, but we're going to play basically the same game as this, although we don't have, right, I don't want to actually plot these. So what we're going to do is find what we did here, 0, 2. We used these 2 points to find slope, rise over run, by the difference of the x's over the difference of the y's. That's how we found this. And then we used one of the coordinates, didn't matter which, and plugged it into substituted it into the equation and found the missing c value and used it to write the slope. We're going to do the same thing here. So I'm looking for like y equals mx plus c. That's the equation. Neither of these is the c value. That's too bad. Oh, I should have seen that. This is super easy. This was the graph. We did too much work here. This is the c value because it's where it starts, right? We should have just seen that and plugged it in. So they weren't that nice to us here. Neither of these is the c value because it's not, one of them should be 0 comma something, right? Like this point is 0 over 3 up. We didn't get that. So all we have here is the ability to find slope using rise and run. So let's see, slope is how much up divided by how much over. The up is the change in the y value, so this goes from 1 to 16. It sounds like an increase of 15. And the run is from -2 up to 3. That sounds like an increase of 5. Divide, slope is 3. So now we know this is y equals 3x plus c. That's really nice. Pick one of the values. Let's pick this one because there's no negatives. I don't know. And plug in an x value and a y value. So I should get out 16 when into the equation whose slope I know. Oh, but the c value I don't know. We put in this 3 for the x value. And then you do a little cleanup. Right, so you get 16, 3 times 3 is 9, plus c, subtract a 9, subtract a 9. This is c, 6, 7, 7. So c is 7. So the equation is y equals 3x plus 7. And if we were to graph that, it would look like this. You'd start at 7. 1, 2, 3, 4, 5, 6, 7. And then this slope is 3 over 1, rise over run, so you'd rise 1, 2, 3, run 1. There's your next point. All you need is 2 points to make a line, and you're done. Good to go. All right, hope that helped. There's some practice problems from your home learning. It's 2-9, finding equations from lines. Try that out. Answers are on the back, and I'll see you later.